All right, in today's lesson, we're going to be talking about equations. So, what is an equation? An equation is a mathematical sentence that contains an equal sign. So, we have expressions, 6x plus 2. And this one, I can't solve it. I can combine like terms, but in this there are no like terms. There's something else I can do with this. Now, there is one thing. They could say evaluate this expression. If x equals some random number, we can put 2. And this expression now we can plug in 2 for x and evaluate it, follow the order of operations, and this would equal 14. So, what's the difference? What if I had x minus 4 equals 12? Now this one, this is called an equation. Why? Because again, it has an equal sign. So, to solve an equation, we have to keep things balanced. We have different properties that are involved in equations. We have the addition property of equality, subtraction property of equality, multiplication, and division property of equality. So I will talk more about that later. So in this equation, I have x minus 4 equals 12. You might be able to do this in your head. What number can I subtract 4 by to equal 12? If you're able to do it in your head, the answer would be 16. 16 minus 4 equals 12. But algebraically, why is that true? So, let's solve this algebraically. So, in an equation, we need to isolate the variable. So what does isolate mean? Hopefully you know isolate means to get alone. Okay? So let's think of the equal sign as a river. Okay? I need my variable on one side. Variable on one side, and my constants, just the number, on the other. Now, it doesn't matter necessarily if the variable's on the left or the right and constants on the other. I usually like to put the variable on the left-hand side because as we graph things later on, let's don't worry about that, but as we graph things later on, it's a lot easier if we have the variable on the left-hand side. So, to isolate it, I'm going to look, what am I doing to the x? On this particular problem, I'm subtracting by 4. Now, to isolate it, I'm going to do the inverse operation. The inverse operation of negative 4 would be to add 4. Why? Because a negative 4 plus 4, well, they cancel each other out. Now, getting back to that property of equality, in a fraction, whatever you do to the top, let's say I have 4/8, I want to simplify it. If I'm going to divide it by 4, on the top, I also have to do it on the bottom. Whatever I do to the numerator, I do to the denominator. On an equation, whatever I do to the left side, I also do to the right side. So again, I had negative 4 on this side, and then the inverse operation. The opposite is positive 4, so that cancels out. So I'm left with x, and over here, 12 plus 4 is 16. That's why it equals, algebraically, 16. Let's do another. X plus 6 equals 6. Now again, this one we should be able to do in our head. What can I add? What number can I add 6 to get 6? Now obviously the answer is 0. Why is that the case algebraically? So I need to isolate the x. So what am I currently doing to the x? Well, I'm adding 6. What is the inverse operation? What is the opposite of adding 6? That's right, it is subtracting 6. And whatever you do to the left side, you do to the right side. This cancels out. So I am left with x, and then 6 minus 6. I start off with 6. I take 6 away. I am left with 0. Okay. Now it works that way for adding and subtracting, but let's just say I have 2x equals 8. So in this equation, what you're saying is 2 times what equals 8? Again, we can do this in our head. We know the answer is x equals 4 But why does it equal 4? How can we solve it algebraically? And I keep on talking about solving it algebraically. Why is this important? Because when we get to multi-step equations where there's several steps involved, it's crazy important that you can solve things algebraically, that we're not just relying upon doing it in our head. So, looking at the x, what am I currently doing to the x? I am multiplying by 2. I'm going to do the inverse operation of multiplying by 2, which is dividing by 2. Well, why? Well, what's 2 divided by 2? Well, it's 1. What's 1 times x? X. So we got rid of the 2. Again, I'm multiplying by 2. The opposite of the inverse operation is dividing by 2. Why? Because 2 divided by 2 equals 1. Whatever 1 or 1, and 1 times x is x. We keep it equal. Whatever we do to the left side, we do to the right. This canceled out. I am left with 8 over 2, which simplified is 4. Now, what if I'm dividing by a number? Okay. What number, on this problem, what number divided by 3 will equal 6? Again, should be able to do this in your head. 18. 18 divided by 3 is 6. But why? So let's look at this. What am I doing to the x? I'm dividing by 3. The inverse operation, or the opposite of dividing by 3, is multiplying by 3. And this cancels out. Why does it cancel out? Because what is 3 over 1? This cancels out. I'm left with 1x. Whatever I do to the left side, I do to the right side, and x equals 18. Now these are solving one-step equations. We also have two and multi-step equations. I will talk more about that in other videos, but hopefully solving one-step equations, again, isolate the variable. So let's erase this. So if I had 3x equals 12, isolate the variable, look at what you're doing to the variable. Like on this problem, multiplying by 3, the inverse operation, the opposite, multiplying by 3 is dividing by 3. We keep it balanced. Whatever we do to the left side, do to the right side. X equals 4. Again, we want to work on solving them algebraically, because again, later on I will show you two and multi-step equations, and so knowing the procedures to solve them will help dramatically. If you have any questions or you need anything, you can email me. Otherwise, good luck.